I grew up as a middle child of three brothers in a suburb of New York City, and in this family, education was not merely emphasized, it was the reason for our existence. And virtually all the aunts and uncles, parents have PhDs in science or engineering, and it was really taken for granted I would have to become a scientist. And so my older brother has a PhD in physics, an MD PhD in molecular biology. My younger brother has a PhD and 2 advanced law degrees, and I could only manage a single advanced degree. So this inferiority complex motivated me to become a scientist for many, many decades. I was a very inefficient student and would often go astray. And during my PhD studies, I started several projects, abandoned them, got interested in something else, finally settled on an experiment to test the unification of electricity and magnetism with the weak nuclear forces. I was somewhat lackluster in that. It took me many years to complete it. In fact, I begged my advisor to give me a PhD, and I would stay, and after 2 more years, I barely got a result. But despite that performance, they made me an assistant professor at Berkeley, which I, to this day, don't fully understand, because I had no scientific publication when they made me the offer. In any case, I immediately spent my startup money, but they also said I could take a leave of absence, and I jumped at the chance to go to Bell Laboratories. And I share Eric Betzik's view of Bell Laboratories. It was a marvelous place. I did a number of experiments there in many different fields: atomic physics, laser spectroscopy, condensed matter physics. And it was there that I demonstrated the laser cooling of atoms and its optical trapping, which was later recognized with the Nobel Prize. I should also mention that the original idea of laser cooling was introduced by Ted Hensch and Art Shallow 10 years before I did the work. So in 1987, I moved to Stanford and I became the first science professor of Asian descent outside the medical school in the history of the university. That was 1987. And while at Stanford, we invented methods to split atoms apart quantum mechanically using the wave-like nature, bring them together, and we showed how to measure how atoms fall in gravity with a precision of 11 decimal places. The irony of this work is that today, NASA is designing a space mission to use that very same technique to measure climate change and how glaciers are melting due to atom interferometry measurements of changes in glacial ice mass. At Bell Laboratories, I also worked with Art Ashkin, and he showed during the same time we were working on atom traps that one can hold on to single bacteria with these so-called optical traps, which we called optical tweezers. And the irony is that he had come up with the idea 8 years earlier, but never bothered to try it. And it wasn't until we were trying it with atoms that he said, maybe we should try this with particles in water. Now, that work was just recognized this year with another Nobel Prize, which I'm very happy about. But when I left Bell Laboratories, I said, all right, Art, you showed us how to hold on to bacteria, we can hold on to atoms. And at Stanford, I immediately started to work on how to hold on to individual biomolecules like DNA, and with Jim Sputich and Bob Simmons, actin-myosin systems. And so that started what I would call a deep scientific promiscuity, in the sense I was willing to become intimate with any field of science. And so in addition to biophysics, I went into polymer physics and biology. And more recently, since stepping down from the Department of Energy, have been doing nanoparticle synthesis, which is now allowing us to probe, transport, molecular transport in neurons which we think will have some influence on trying to understand the root cause of diseases like Alzheimer's. That remains to be seen, but we are now collaborating with two groups in order to explore this. Now, as a concerned citizen, I became interested in climate change, began to read about it, and began to think that perhaps there is some truth in these early warning signs. This is around the year 1998, 2000. And as a result of that, in 2004, I was asked to become director of Lawrence Berkeley National Laboratory. I said no twice. It turns out you have to say no 3 times. Biblically, that is the tradition. And the third time they asked me, I said, well, maybe I'll show up for an interview. And I took the job. The reason was I began to talk about climate change several years before that, and I thought, if I'm talking about it, but not willing to vote with my feet, why am I talking about it? So I did join Berkeley Lab with the intent of trying to inspire people to think of what science they are doing and what expertise they have, and could it lend to new science and discoveries that could give us better solutions. And no deed goes unpunished, and 2 weeks after the election of 2008, I got a phone call and was asked to meet with President-elect, who then asked me to become the next U.S. Secretary of Energy. I was the first scientist to hold a cabinet position in the history of the United States, which may seem a little surprising. So I'm the Jackie Robinson of scientists. But as a practicing scientist, I was able to recruit a number of personal friends and to join the department who would not have think of working for the government. And that was a real joy in working below the radar to do this work. Now, in addition to the Nobel Prize, I'm going to spare you of the other awards. I am a member of a number of honorific societies. I just mentioned a few: the National Academy of Sciences, foreign member of the Royal Society, the foreign member of the Royal Academy of Engineering, the Chinese Academy of Sciences, the Korean Academy of Sciences and Technology, and actually the National Academy of Belarus. Now, in addition, I am the president-elect of the American Association for the Advancement of Science, and become president this coming February. Now, I say that because the AAAS is founded in 1848, and it's the largest general science organization in the world, and its mission is to, and I quote, advance science, engineering, and innovation throughout the world for the benefit of all people. And so this discussion at this meeting is particularly relevant to the mission of the AAAS. Now, in closing, I will add that although I have only one real PhD degree, I've at long last caught up with my brothers. I do have 32 honorary degrees.
And something which most of us do not have, the experience to talk